Hello everyone, welcome to ashatech.com. Today we are going to discuss a very important topic called differential equations and alongside the modeling. A differential equation can be defined as an equation involving an unknown function and its derivatives. Differential equations are of basic importance in engineering because many physical laws and relations appear mathematically in the form of differential equations. There are various physical and geometrical problems that lead to differential equations which come as a result of modeling the physical situation or the transition from the physical situation to a mathematical model. Here the model will be a differential equation which, when solved, depending on the order and the degree, also depending on the prevailing parameters, will give a solution that satisfies the equation. And therefore, when you explore its properties, graph it, find the values of it and interpret it in terms, in physical terms, we are able to understand the behavior of the physical system in any given problem. Now let us look at the examples of scenarios that can be modeled using differential equations. This can be a falling stone freely under gravity or free fall under gravity. We can look at the motion of a parachutist in his parachute. We can also look at water flow out of a tank so that we ascertain the level of water after a particular time t, or to find how much time it will take to have all this water flow, or to have water flow between specific points which could be given in a problem. So to give an explanation in details of the above scenarios, we are seeing that a falling stone can be defined by a differential equations y double prime equal to g, and g is a constant which is the acceleration due to gravity. And therefore this can be rewritten as the 2y dt squared minus g equal to 0, and whereby y is the vertical displacement of the falling object, and it is actually a function of time. And it is therefore, when you look at the 2y dt squared, it tells you that this is a second order differential equation. We will look at the solution of such problems in the near future. Problem number 2, or scenario number 2, is the motion of a parachutist. If we look at a parachutist, the equation defining his motion is mv prime is equal to mg minus bv squared, and this is from a scenario if we consider weight, the total weight, a force due to weight acting vertically downwards, and also the drag force trying to oppose his motion. And if the acceleration is vertically downwards, then it means the resultant force is going to equal to mg minus fd. Fd is the drag force which is directly proportional to the square of velocity. Therefore b is a constant and v is velocity. So therefore this resultant force is equal to ma according to Newton's laws of motion. Ma is equal to mg minus bv squared, whereby acceleration itself is the first derivative of velocity. So if we substitute it in here, it becomes m dv dt equal to mg minus bv squared. If we simplify it, it will give us dv by dt plus b over mv squared minus g. This is the first order differential equation which can be solved by a number of ways. So we can use the separation of variables and be able to solve it. We shall see that one in the future. And if we want actually displacement, then that displacement will be the second order, because if displacement is y, then it means velocity of that body will be dy dt. So dy dt is equal to velocity. So it means if we want dv dt, we shall differentiate this one, which will give us dv dt equal to d by dt of dy dt, which gives us d2y dt squared. And this would be a second order differential equation that will give us the displacement of the body, which is the parachutist. What about another scenario? The differential equation for time taken to empty a tank, or the rate of water flow out of a tank. According to how this problem is solved, it is found out that the rate at which the water is flowing is equal to negative k square root of h. So the h dt is equal to negative k square root of h. And this equation can give us how much time it takes for a tanker to be emptied, or how much it takes for the level of water in the tank to fall between the 2 points. Or it can also tell us how much will have gone outside the tank, or the level, the change in level in a particular time. So the differential equation is the h dt plus k root of h, which is equal to 0, and this is the a differential equation of order 1. Thank you so much for watching. See us in the next lecture.